Sorry, I'm just making sure this shows up. Perfect. All right. Hello, everybody, and welcome to what's probably our first live stream U of T Coder session. So we typically start every U of T Coder session with a quick introduction about the group and how to get involved. U of T Coders, if you're not already familiar, is a group led by and for grad students and researchers around the Greater Toronto area that specifically revolves around sharing programming skills in a beginner-friendly and just generally welcoming environment. Unfortunately, of course, today we can't hold an in-person event given recent public health developments, but we're just going to be live streaming our lesson in its entirety instead. Of course, this is our first time doing this, so there may be a few hiccups here or there. But of course, please, we'll do our best to make it slick. Just bear with us if anything does go awry from here or there. If you'd like to get involved with U of T Coders, feel free to drop us an email or check out our website. I'll be posting both of those in the chat. Typically, I would just ask you to talk to myself. My name is Ahmed, and I'm the president of U of T Coders. But of course, we're not really in the same room, so digital communication will have to do instead. Our events are typically held at the Mad Lab at Gerstein Library every other Thursday at 6 p.m. Again, given the situation, we may continue to live stream those, but they will still, for the foreseeable future, still be held on time. So with that, I'm going to hand it over to Jesse, who is our instructor for today, and will be talking to us about continuous integration with examples in Python. Take it away.
Thanks, Ahmed. Okay, cool. Yeah, hello, I'm Jesse. Yeah, I'm happy to be delivering this at all, I guess, given the situation. But yeah, just happy to get started. In a moment, I do want to ask kind of where people are coming from in terms of background, so I can have some context for things we might get hung up on, or ways that we can make this most useful to you. A little bit about my background. I'm a PhD student at Toronto. I'm working in the Institute of Medical Science, actually, but I do epidemic modeling, which obviously is quite relevant at the moment. So that's kind of fun. I use Python pretty regularly. I've also had some experience in MATLAB and a tiny bit in C, a bunch of web stuff. I've mostly been self-taught, not a lot of formal courses, but it's kind of fun to learn these things, and basically everything that I'm going to be presenting today, it is also self-taught. So for better or for worse, these are my experiences. Hopefully that makes it easy to understand, and but I may be missing some kind of theoretical aspects that are more interesting to those types of people. Anyways, let's get started. The overview for structure-wise, just going to be doing a brief PowerPoint here, and then we'll actually do a code along, which should take the majority of the time. And during that, we'll actually build a Python project with a repo on GitHub, and we'll integrate some of the continuous integration features that exist, namely Travis and code coverage. Yeah, so we'll get started. Actually, yeah, like I said before we get started, I do want to know where people are coming from. So maybe you could type in the YouTube chat who you are and maybe what your background is, and something like that. And I think there's quite a bit of a delay here, so I'll give you guys a minute to do that. Then in the meantime, I guess I'll just move on and I'll read those as we go, because I think the delay is at least a minute. Cool. So what's the problem that continuous integration is actually trying to solve here? The first thing is we have a code project that's kind of increasing in complexity. It has maybe a lot of components that are dependent on one another within the project itself. You may also have projects downstream that are reliant on this particular project. And so as the project grows, you don't want to actually break those dependencies, or at least if you do, you're going to tell people. You may have actually many different contributors to this project. And you may have users coming from different operating systems, hardware, versions of software like Python or whatever. And And then the other aspect of it, not only is it a complex code project, but it's also the development is ongoing. So you're adding features and you may be kind of refactoring things, right? So how is it that we make sure that nothing breaks, basically, throughout this whole process here, as we're continuing to grow the project? And it's pretty common once things get big. But I would also say that, personally, if I'm working on something that I plan to reuse a piece of code for the majority of my thesis or something like that, it is good practice just to kind of get into building up these tests around your code and making sure that nothing breaks for yourself, and also potentially lab mates who are using your code or whatever. So a nice example of a library or a package in Python that's actually using continuous integration, and there are many, but this is kind of a bigger one. It's PyTorch. It's a deep learning framework. It has 1,300 contributors over, 24,000 commits, which are like individually itemized changes, for those of you familiar with GitHub. It runs on all the major operating systems, and it also has pretty low-level GPU hardware support. So there's kind of a lot going on there, a lot of moving parts. And considering that the project is continuing to grow, it's really impressive that things aren't really broken. What are all the checks and balances that make sure that actually happens? I would generally call that continuous integration. I do just want to pause here and note that no one replied to my question here, so I don't know what your backgrounds are. But maybe we'll come back to that before we get into the code alone. So please reply that in the chat. Okay, so like I mentioned, continuous integration is actually the solution to that problem I described of growing complexity and continuous development. And what actually is continuous integration? I was talking to Ahmed just before this, who was saying most people these days kind of think of continuous integration as this downstream component of like automated testing. But reading online, I realized that something we take for granted now, which is version control, would also kind of fall under the continuous integration scope. So first of all, it's version control. And version control basically is any way of tracking differences. There's a terrible thing called SVM. I forget what. Anyways, it's not as good as Git, and it's a real pain in the butt to use. But the major one that almost everyone seems to be using these days is called Git. And some people may not know that that's actually different than GitHub, which is a repository software. So it's a way of taking those version-controlled versions of the code and basically hosting them all online, so that if your laptop, fries itself or whatever, then you still have another copy of it. And it's also obviously useful for multiple contributors. I see there's some comments in the chat now. I'll come back to those in a minute. Regarding the next aspect of it, it's testing. So it's how do we actually make sure every part of the code that we're writing is actually doing what we expect it to do. So some aspects about that we might want. First of all, it's fast. We want that to be easy. So for example, in this examples, the code along, we're going to be using PyTest. It's a framework just for Python that makes writing certain test modules really nice. There's much more general ones for multiple languages, and there's other ones for Python as well. And then there's this idea of automating these tests. So whenever we are taking a version and pushing it to the remote repository, we also want to run a bunch of tests. That might not be every version that we push to the remote repository. Then we get into things like branches. So we might have a branch that is experimental stuff. But then when we merge that with the master branch, when we take all those changes and we say, these are all ready to be integrated in the main flow of the code, then we want to run some tests. And so there's a tool called Travis, continuous integration, that we'll look at, that will automate running those tests. And then we also want to make sure that our tests are actually thorough. And so there's a way of actually checking every single line in our project, every line of code, did it get run during the tests? And so that's what we call code coverage. And we'll be using a tool to check that. So That's continuous integration. I've been talking a lot already, and we haven't done anything fun. So let's actually get into a code along. And actually, at this point, I'm going to stop. I'm going to look over at this chat here and say, people are nervous. Yes, I would agree. Ahmed, he's a PhD student. He's working in evolutionary genomics, some familiarity with Git, and new to CI. Sounds good. I think that's probably most people out there. So let's actually do the code along. So the goal of this, like I kind of mentioned in the introduction, is going to be creating a minimum working example Python project. Okay, so we're over here with Adam, our favorite text editor. Please open up your favorite Python text editor. And the very first thing that we want to do once we're here is we're actually going to make a tiny little Python package. And then we're going to actually kind of write another little debugging file that will actually use the package. So again, the kind of context for all of this is the fact that we're writing a package that's reusable. You may want to write a script that actually does something very specific and have tests around that. But generally, the kind of best use of continuous integration is to test little modular components of a package that's kind of more general purpose and might be used by many different people. Okay, so very first thing we'll do once we're actually in here is we'll create a little folder, and the folder will be called project or package. No, project. Okay, so the name of our Python package is going to be project. Okay, and then in project, we'll make a new file, and this is going to be called ops.py. Okay, so ops.py is basically going to do a few very simple things for us. This could be the main parts of your package, but for the sake of the demo, I'm going to make it really, really simple. So let's make a function that literally just adds two numbers together. Okay, so we'll say def add nums or add fun, a and b, and we'll return a plus b. Great. Let's do the same thing, def sub fun for subtract, a and b, and we'll return a minus b. Great. Oh, first of all, is everyone seeing both of my screens? Ooh.
Yeah, I can see both.
It's kind of small, hey?
Yeah.
I don't know how much I want to tinker with this. Maybe I'll just disconnect this other screen.
Okay, so you're still here and your audio's still here, so we're good.
Yeah. I don't want to share the entire screen. I want it to be smaller. I think I'm going to close these over here, and I'm going to...
Okay, we could feasibly have both and then just increase the text size on one of the screens quite a bit.
Oh, true, yeah. Yeah, let's do that. Let's not tinker. I don't want to screw anything up anymore. Okay, let me go back to Adam, and let me increase the screen size, or the font size a bit. Here. That's not the right one. There we go. Entire screen. Oh. Cool. I'm back in Adam. Okay, hopefully you can see that.
Yeah, it looks a lot better to me.
The problem is there's a few things in the tree here you probably want to look at. Okay, so let's make next that debugging function, which is actually going to use our package, basically. Okay, so we'll make a new file, and we'll say from project, right? Actually, let's first of all name this thing. So we'll call it, we're not going to put it in the project folder. We're going to keep it outside, and we're going to call it debug.py. Okay, and I'll leave this here so you can see that over there too. Okay, so we're going to say from project, meaning our project here, we're going to import add fun and sub fun. Okay. And then we're going to say print add fun 1 and 2. Okay. I have a slightly different setup here with Atom than you might have with one of your editors. So the other thing that I need to do is create a little make file, but I also find that helps with reusability or reproducibility. So this is going to be my make file, and I'm going to say, oh geez, what's the syntax? It's been a while. Debug, phony debug. And then we'll say Python debug.py. We'll call this make file. Cool. I think that's right. Now I can run it from here. Missing separator. Oh no. Oh geez, I gotta open up another one. Oh, there we go. Gotta insert an actual tab. Okay, so cool. Now we got some output here. And actually, we're expecting to fail at this point. Okay, so again, Python debug, that's all the magic that's happening in Makefile for now. Okay, so in the output here, we're saying in debug, line 1, we're trying to import from project add fun sub fun, no module named project. Okay, so the reason that that's happening is because we actually haven't made what Python would consider a package yet, because we need the magic command called init, which is actually just a file within project. Okay, so basically to fix this, we make a new file. It can be completely empty, and all we got to do is save it under project, then project called init with 2 underscores on either side, .py. Okay, so that's underscore underscore init underscore underscore .py. Okay. Now Python will find this folder here, and it sees init in it, and it says, okay, this is a package, and I can import things from it locally. Okay. If it's a more advanced project, you might want to put certain things in your init function or in your init file, but for now we can leave it blank. Okay. So now we can run this. I think. Oh no. Oh, right. Now we found the project, but we actually want to import a module within the project called ops. And ops will contain the functions add fun and sub fun. Oh, I'm a mess. But these are things that you might run into, so maybe this is helpful. So we actually want to import the module called ops, and then we're going to do ops.addFun as a function that we might find in the module ops, which of course we do. Okay, so now this should actually run. There we go. And we printed add fun 1 plus 2 gives us 3. We're happy. Okay, so there's the tiniest possible Python package that you might want to create and how you can use it locally. Okay, you can see we've got some cluttered up executable files. You might want to ignore those in the future. Okay, so briefly returning to, oh, do I have my slides? Oh no. Let's see if I can log onto Google Slides here. Go back to my presentation.
I can take you off your screen off for a second while you log in and stuff.
Oh, that's fine. I'm already logged in.
Oh, that was quick.
I mean, yeah, it's cached or whatever, for better or for worse.
True, true.
Okay. So we've created a project. Now we're actually going to test some of the components in that project. Okay. Well, that's all the glory I needed to get from there. we'll go back to Atom. So the next thing we're going to do is we're actually going to write another folder in this project that will contain all of our tests. Okay. I kind of glossed over this, but if you were setting this up as a GitHub project, and this was going to be the code that corresponds to your actual package, it's always best practice to actually leave the source code for the project itself that someone might load in another folder called project within the thing. So you can see this is where we might have things like a README under, event would actually be called project, like the GitHub repo called project. And then within project, you'd have another project here. And then you'd have your README. Because outside here would be things like testing, documentation, all these other things. And then the actual source code would not live at the root, but it would live in this subfolder here. Again, some of that might be like basic stuff when you've browsed enough GitHub repos, but probably worth noting if you're ever wanting to read the source code from a project that's kind of big. So like I mentioned, now we'll make another folder within this kind of root here, which again should really be called project. And we're gonna call this tests. Okay, and this is where all the code corresponding to our tests is actually going to live. Okay, so let's actually make one of those. And we'll call this tests.testops.py. Okay, testops.py. And its job is going to basically be to test all the functions that exist in ops over here. Okay. Within here, we're going to want to load in the package called PyTest, which, like I think was in the email, is how we're actually going to be running these tests. So we'll say import PyTest. And if you're following along, oh, actually, we haven't run this yet. If you don't have PyTest installed, take a moment right now and go pip install it. Okay. So the way that PyTest works is it's not an actual Python file. Like, we're not going to call Python testops.py. We're actually going to write PyTest right into the command line. So like PyTest. And then instead of the name of a file, we're going to give the name of a folder, and it's going to run all of the different files within that folder automatically. And then it can kind of summarize the results for us in a nice way. Not too important, but it's just some people might get stuck on there. And so back in our make file, we're going to add another option here, or you can just type this in the command line directly. Phony. It's going to be tests, and this is going to be tests PyTest tests. Okay, so PyTest is the actual command that we're running as if we were in the command line, and then tests is the name of the folder relative to makefile. So tests here. And it's going to contain all the different files. I think you could probably call the files individually here, like test ops, whatever, if you wanted, but this will run the whole folder. Okay, so in Atom, that automatically gets indexed, and I'll actually try running PyTests, which of course does nothing because we've started the test session. It tells you a little bit about the things that are being used. So around Linux, we got 3.5 Python, some different versions of things, whatever. And it says we collected 0 items, and also we actually ran no tests because, of course, test ops is actually empty. So let's actually create some tests. The way PyTest works is every single test is actually just a function. So for those of you coming from unit tests, where you start to create classes for different tests, that gets quite cumbersome, and having used a little bit about both, I much prefer PyTest because it's just a lot faster to build stuff. So we'll make a function called test ops or test add fun. And kind of convention is to just take whatever module, whether it's a method or a function or whatever over here, and then just prepend test underscore, just for readability. Doesn't have to take any arguments. You can if you want. And then in here, we want to actually say, we actually want to write a bunch of code that should all not throw errors, essentially. So we can say things like assert, add fun, AB, 1, 2 equals 3, right? That's what we expect. Okay, but of course, this is a Python file, and we haven't actually loaded in add fun. So in the same way that we did this in debug over here, we got to load from project import ops. So we're actually loading in the module in our own library that we're trying to test. And then this is actually just going to be called ops.addFun. Okay. So now I'm going to try running our test. It actually ran. And of course, nothing actually works the first time you do it. And I believe this time the error is because tests also needs to be a package. So we also need to take this file and put it in tests. So now we have init.py and tests. I hope that fixes it. There we go. Yeah, that was the problem. Okay, so again, to fix that error, we need another PyC file in tests. I don't really know why that is necessary, actually. I guess somehow under the hood, PyTest is making a package out of your tests folder. So that's kind of fun. So yeah. Oh man, I really wish this was live because I would like to stop at this point and ask if you have any questions. And of course, I've closed down. Oops. Let me see if I can open up the old tabs. No.
I don't think we have any questions at present still.
Okay,
but
cool.
If you want to take a second to open that up, that's fine too. Just as I mentioned.
That's fine. Okay, so
sorry if I could just interrupt for a second again. Audio's been super consistent and clear so far. I think it was just that your kind of audio block is the best way I can describe it, was dropped from the StreamYard studio thing. If you want, now might be a good time to try do the single screen thing. But it's up to you. We can continue with this if you're kind of feeling averse to that.
I closed down the other stuff. How's the readability from that size?
So the readability for the size is good. It's more the sidebar being small means that the structure is a little hard to see. Okay,
that is actually quite important. So I think I will take your advice here and
that's the only reason I'm kind of poking my nose in.
Appreciate that. So I'll just drop the other screen and see what happens.
Okay, and now I know what to look for if the audio happens to drop.
Oh, did it automatically figure itself out? Hey, I think so.
Looks it, yeah.
Great.
Awesome.
Nice.
That looks really good.
Can you see this little Firefox thing here?
I can, yeah.
Oh, that's kind of annoying. I don't know why it's there specifically. I can't move it. Oh, there we go. There we go.
Okay.
Let's put it over there. Okay.
Just off in the corner.
Cool.
Awesome. Thanks.
So we could do similar things, def, test, subfun, assert, ops, subfun 1, 2 equals -1. We could run this, and you could see now we have, instead, I don't know if you noticed before, there was only one dot here, but basically each of these dots, as it's processing, kind of as way of like progress bar, you can see we've run 2 tests. And each test, or each dot basically represents a function in here, in PyTest. And this 100% has nothing to do with how many of the tests you've passed, has everything to do with the progress through the testing suite that you are at when it fails, if it does. So let's say we say this actually is supposed to equal 0. We run the tests. This will fail. And you can see, oh, it actually finished running all the tests, but you can see we get an F here because we failed this test because 1 minus 2 does not equal 0. Okay. And then it's nice. It will continue running all your tests. So if we have more tests down here, whatever, it will finish running them, I believe, unless they're critical. And it'll say, oh, I just hit a failure here. I captured it, and then I moved on. And you can see here, it said assert minus 1 equals 0. That's obviously false. And then it gives you some other info here in case that's relevant for your debugging. Cool. So, of course, one thing, and I'm just to highlight, I am putting this back to the expected behavior, so it shouldn't fail anymore. So a really important part of testing is actually making sure that certain things do break, but they break in a way that we expect. So that's one of the really nice things that I like about PyTest. It has this thing called raise. So you can say with PyTest raises, sorry. Let's say type error. So errors in Python are objects, and type error is a subclass of error, basically. So with this raises type error, we can actually try to use add fun wrong. Okay. So we can say, oh, please add 1 and the string called 2. And now when we try to use this, it should say, okay, like 1 is a number, but we're trying to add it to 2, but that's not actually, that I don't know how to do that without you coercing something in a dangerous way that R probably would, like the devil it is, but we wouldn't do that in Python. So F's in the chat. So we'll run this, and we should see that all of our tests actually still pass, right? And there's nothing wrong. Everything worked as expected. Kind of gloss over that we can actually have many of these different commands in here. So 1 and 3 gives us 4. All of this is still going to correspond to 1 dot. So it's kind of up to you, what resolution of test you want. If you want to have a bunch of tests all in one thing, it doesn't really matter. It kind of gets cluttered when you have a different function that tests literally every possible thing. So we can just leave it here. But, by this convention, basically we're testing all the behavior of this one function in this testing function here. And we'll see that add fun 1 and 2 has thrown a type error. If we tried to do that outside of this environment, so let me comment that out, and we'll just try to run this as a test, even just by trying to execute this, this will fail, and as a result, our test will fail. Like this. So it said type error, unsupported operand types plus for int, which is our first argument, and stir, our second argument. So obviously the same thing would happen if we had something like that. And basically we could make sure that the behavior is the same within, for depending on which argument you're using, by throwing them both under this. Oh, actually, no, this is the thing you're not supposed to do. So what'll happen here is the code will get to here, it will throw a type error, and then it won't execute the rest of this. And so you actually haven't tested this test case. So you do actually need to repeat the widths for every single case where you expect to throw an error. I don't know how I can demonstrate that. Let's see, like assert true equals false. So this should throw an assertion error, but you can see all of our tests will actually pass here because first we threw a type error and we never actually got to the assertion error. But if this is commented out, we'll throw an assert. We will fail a test because we were supposed to throw a type error but instead we threw an assertion error. Okay. Don't worry too much about that. That's a little bit more advanced, but do make sure that when you're writing your tests, every time you're expecting to throw an error, you have a different with statement for every error. Okay. Cool. We can get a little bit more specific here. Again, this is the stuff we're testing over here. So when we throw this type error, maybe we want to make sure that it's an even more specific type error, because usually they have kind of descriptions. So let's comment these guys out, and we'll drop those guys down the indentation scope. And we'll see the error we expect is actually we want to see unsupported operands of type plus for int and stir. And then then I think it failed after that. So we'll comment that out on the next one. And we can't convert int to object to stir implicitly. So we actually see that what we've gotten here are two different assertion errors. And that's just because of the fact that A is appearing first. And so it's kind of trying to add B to A and maybe coerce it if necessary. Or, and so it's actually treating A and B slightly differently. So there's a few different, I mean, we might be happy with this behavior, as we originally had it, like that. We're just throwing type errors, but maybe we actually want to control this a little bit more fine grain. And so over here in our actual package, let's actually add some additional assertions. We can say assert, is class, I think, no, is instance, A, and then we can try for an int, or maybe a float, something like that. And then long type. How do we actually do this? Oh, it'll just be an assertion error. Yeah. So now when we actually run this, because A isn't an int or a float in this case, it's going to raise an assertion error. And then this case is actually going to fail because this is not an assertion. This is not a type error anymore. Instead, it's an assertion error. So we can run that test, and we'll see that. Say we were looking for a type error, but instead we got an assertion error because A was a string, not an int or a float. Okay. I forget exactly what it is here. I think we can do comma, wrong type. I think it's going to throw, yeah, it'll actually print that out for us, which is what we want. Oh, I don't have to be so large anymore. I'm going to decrease the font size so that we can actually read that a little bit. Okay, so the next thing that we can do, first of all, we need this one to be an assertion error. And let's do it for both, because now we're going to have a little bit more fine-tuned control over the errors that our package is throwing, because we're actually writing them in. Assert is instance. What am I doing? Let's copy all this. And we want to do the same thing for B. As an aside, I'd actually recommend against doing this sort of upfront error checking. I think usually the default error checking that happens at this level in Python is usually good enough. And computing these assertions in a package that you may be interested in speed is actually going to be more computations. So unless it's absolutely necessary, I wouldn't add a lot of your own assertions. But it depends how much you care about speed. So now we're going to raise assertion errors, and we're going to pass both of our tests. So this should be fine. Great, we passed. Okay, but the functionality that I wanted to add to show you here is that we can actually say, not only do I want this to be an assertion error, but we also want the error text to actually match some string. Okay, so this test is going to fail because the word apple does not appear in wrong type. Okay, but this test is going to pass because we're going to say even just type would be sufficient, because it just has to be any component. It's actually using regex. You can use fancy stuff in here, but I'll just use the full thing here. So we should have one failed test. Pattern apple was not found in wrong type. Okay. So this guy isn't working as expected, but we'll add wrong type in there, run our tests, and now we have 100% pass. Okay. To the ether, any questions? Questions? Can't really hear anything. Okay, moving on. We're basically going to repeat something similar for our subtract function if you wanted. Again, I'm going to decrease the font size so we're not wrapping. And then you can imagine how we might want to copy these tests down here. I know it's not good practice to copy code, but we might have subfun. If you're following along, maybe don't even bother copying this stuff because it's very repetitive. But you can see how we could kind of have regular stuff. You might even loop through a bunch of stuff here if you pass these functions as objects or a list of objects or something like that. But you get the idea. So we run this and hopefully it should be good. There we go. Sounds great. Okay, so that's testing briefly. It could get a lot more complicated. Yeah, it could get a lot more complicated. But for our purposes, this is sufficient. We have some tests. They're running and they're passing. So now we're going to get to the actual meat of this, which is integrating this stuff with continuous integration component like Travis. And in order for us to do that, the next thing we need to do with this whole stuff is create a GitHub project about this. So I hope you can still see my screen when I go over to Chrome here.
Yep, sure can.
Sounds great. Okay, so on GitHub, please go and log in. Oh, I'm logged out. That's weird. And then we'll go over here and we'll make a new repo. Okay, I'll slow down a little bit here because in case you're following along, that moved pretty quick. So log into GitHub, go over here, make a new repo. And for me, I'm going to call this project, which is the name of the package that we're making. Demo project of PyTest, Travis, CI, and code gov. At this point, please don't make it a private one. Make it a public one. You can delete it after. There's some downstream things that break when we use private at this stage. So it's just a lot easier if we make it a public one. And I also prefer not to initialize with a README. It can cause some merge conflicts in a minute. So just leave it without a README. Okay. So create a repo. It should make that dummy page for us like this. Yeah, we could copy this if we want, or whatever, however you initialize your Git repo. So git init, git add everything, commit, first commit. Oh, we've added all of our PyC files. We'll undo that in a minute. And then git remote add origin project and git push upstream origin master. Success. It is definitely sufficient to copy this into your terminal, but it just feels wrong, so I try to avoid it. Okay, so now we have a Git repo, and you can see in Atom, I now have a Git hidden stuff here that you normally can't see. Okay, cool. So it's a Git repo, and because we've pushed, when we refresh this page, this stuff will disappear, and you'll actually see the content of the repo, like that. Cool, cool. Again, I'll kind of vamp here a little bit in case you're still setting up the Git repo. And maybe for best practice, while you're still setting up your Git repo, don't worry about this, but I'm going to add a git ignore file. And you don't have to follow along. Oops. But, oops. And probably PyCache.
So can I actually chime in with a question?
Yep.
So in testops.py, I mean, I was thinking about this earlier, but kind of kept mum, but it's kind of nagging at me. When you went from project import ops, actually, no, I realized, well, why do you have to explicitly add when referring to add fun, why do you have to precede it with ops and explicitly make the namespace explicit? But I'm realizing that you didn't actually import those functions directly. You actually imported ops from project. So
yes.
Okay.
I did that for scoping reasons in case, there happens to be another module within project that also has an add fun.
Right.
But you're absolutely right. You could also say project.ops import add fun subfun, and then get rid of these everywhere.
Totally, yeah. But that's probably less, I don't know, safe.
Yeah, it really doesn't matter.
Cool. All right, thanks.
But I almost mentioned that earlier, and I, for some reason, chose not to. Yeah.
Oh, fair enough.
So git ignore should be fine. And I'll just add my git ignore file. Cool. And I might actually close this and open it up again, just so that gets applied to my tree over here. Cool. Okay. Now I'll try to recreate what I had open before. Something like this, maybe. Okay. So now we have a GitHub repo. And we've pushed at least one commit probably to it. And so the next thing that we want to do is actually add our continuous integration stuff. For that, for people who are brand new, the very first thing that you need to go is go to travis-ci.com. And at this point, I should probably log out so that I can see what it looks like. So at this point, you'll probably be here, and you can say sign in with GitHub, which is probably what you want to do. It'll probably ask you to authenticate some things if you haven't already configured it at least the first time. So again, I'll give you a couple minutes to kind of figure that all out. And if you've already had it figured out, maybe I'll just briefly walk you through what this actually looks like. You kind of have a history of builds on here, and basically every time you push some commits to GitHub, and you can specify a particular branch if you want as well, it's actually going to run your whole test suite, and it'll say whether or not it either passed or maybe it failed, and then you can kind of explore why. And basically, more generally, maybe what I should introduce is Travis CI is just an automated way of running code, but it also allows you to run that code with a variety of different environments that you may not have available easily for you. So not only can you run all of your test suite with a particular version of Python on a particular operating system, but you can specify many different operating systems and versions of Python, and they'll all run the test suite in series, and hopefully everything will work. For simple projects, probably not that relevant because you don't expect different behavior under different operating systems, although obviously Microsoft path names might get ugly because Microsoft is stupid. But it's a really nice way of kind of having that all happen easily. And again, every time you push to master, you can have these things run. You can configure that too to run at only certain times or whatever. But yeah, hopefully you've got that all set up by now. And now I think I want to go back to my profile, and then here, settings maybe. I think at this point, yeah, you'll want to go over to settings on Travis CI, and you'll want to go to manage repos on GitHub. By default, Travis, I think, wants to read all your repos. Probably not necessary. I don't know if it's going to slow anything down or anything, but I prefer to actually select them manually. And in this case, the new one I called was called project. Yeah, so let's add project, and we'll approve and install it as a little app add-on to GitHub. There we go. And we should have the new one added here, project. Okay, so I'll go back over to my dashboard, and you can see that project has never been built yet. And that's because we haven't actually triggered any builds. And moreover, we haven't actually configured anything within the project to tell Travis how we want the build, meaning the run of all the tests, to actually happen. Okay, so that's the thing that we're going to do now. So we'll head back over to GitHub, or sorry, to Atom, or your editor. And for me, I'm going to create a new file called .travis.yaml, YML. So that's actually the name of the file. .travis.yaml. If you're on Windows, that might be a little hard to actually name it that. I don't remember how to do it, sorry. Okay, so in travis.yaml, there's a few kind of key aspects you need, and I was going to just walk through them audibly, but maybe it's worth probably reading the documentation, like any good user. Customizing the build, you can actually read the build config file. Well, yeah, here's the documentation. Maybe I'll let you read it on your own time. You can read how to actually configure your travis.yaml file. But essentially, maybe stepping back a little bit, the existence of a file called travis.yaml in your project, when you have added that project to Travis through GitHub, every time you push a new commit to master, Travis is going to run all of your test suites, depending on what's in this Travis file. Okay, so the first thing, I'll just have to do this from memory, sorry. The first thing that you need to do is tell Travis whether or not you need administrative privileges. So for Linux, it's called sudo. And in our case, there's no reason why we would need sudo privileges for our test suite. So we can say sudo equals false. The language, is Python. Okay. And then I think there's a default version of Python that would get configured if you just left it as that. But let's say you wanted to say, oh, actually, among Pythons, the way that we could tell it, which particular versions of Python we might want to use, we would say dash, like markdown kind of bullet list, and then 3.5 in quotes, potentially maybe 2.7, in that order, and then 3.8, the latest or something. This is what I'm using, so that's why I want to do that. And actually, I'm gonna get rid of these other ones, but in general, just so that you're aware, this is how you can specify different versions of Python. The next thing that we need to do is tell Travis, how do we actually configure this project? So in addition to, given that it's using Python, so it's probably going to have a Python package loaded on the little virtual environment that would run all of our tests, we're also going to need to install a few dependencies. So the configuration word for that is called install. Oh, geez, I forgot. I think this is just like everything that happens before the tests. So this could be arbitrary commands, but it's pip install for me requirements.txt, which we have not created yet. So we will go and do that in a moment. I think for now it's just going to be PyTest.
I'm just going to pop in with a comment from the chat. Apparently sudo false is no longer needed.
Yeah, cool.
Which is pretty nifty.
Yeah, that's great. Oh, so people are right there. Okay, cool. Well, it sounds like people already know what's going on here. Then I don't know.
That was Elliot, who is who's on Coders Exec and is a knower of many things.
Great. Okay.
Yeah.
Well, I hope this is new to some people at least.
It's new to me.
Okay, great. Okay, so then we've got pip install some requirements. Oh, geez, I forget what the name of this. Please excuse my cheating here. This is my one from the demo. Okay, the sudo is false, not needing any more. Pip install. Oh, let's also add the -r for add all the dependencies. And then this is where the magic happens. This is the actual things that we want to be executed by Travis as part of the build. And basically, if any of these things throw an error, the build will fail. I mean, the build will probably also fail if you have an install fail, but more semantically, we can say, here are some things, PyTest. So this is what we've been having in our makefile anyways, just like that. We'll come back to the cov stuff in just a moment. Okay. And same with after success. Hopefully the email notifications are false by default, but just in case, you can say notifications email false. I'm going to close that. So this is our Travis file, and we'll configure the build. That's pretty nifty. Now, let's just try adding, this new one file to the Git. And when we commit it, basically Travis will see it and say, hey, I need to run a build. And it will execute, this configuration and run all the tests. And then we can get our pretty badges, which is, of course, the goal. So in here, we'll do git diff by default doesn't find new files, so that's fine. So we'll git add here, which is going to have our our new Travis file. So we'll commit that and say adding Travis. And we'll push it. Bam. Okay, I'll keep that over there so you guys can see this here. And then maybe I can hide this down here so you can still see stuff. Oops. And here on the dashboard, hopefully we can see that project, yeah, this hasn't built yet, but it is running. So you can see here, it starts to collapse certain things. It says, okay, here's the host name, blah, blah, blah. A lot of this stuff you don't actually need to know. Builds information, you can see it has using a Ubuntu 16.04, has some operating system information here. And again, if you were to specify, I think, different operating systems here, you know, you could test it on Windows, you could test it on whatever. We've loaded certain Python stuff. Oh, cool, we failed. Nice. Oh, of course, we never made the requirements.txt file, which I said we would do. So let's go ahead and do that. You can see how easy it is to fail builds, and it's exactly why you do the tests. So I'll make a file, requirements.txt. It used to kind of bother me that this file was living at the project root because it was kind of annoying just sitting there. But I appreciate that everyone, you know, looking at a project for the first time would want to know that type of information up front. So it is kind of nice. And in this case, we're going to do PyTest. I think that should be sufficient. And we'll git add everything, git commit, adding requirements. It's almost like I planned this so that we could see what happens when a build fails. I really didn't. And then git push. So on build history, we can see, oh, now we've got a second build happening after adding requirements. I'm not sure what happens if you get bumped down a queue priority when you push too many times, but for small projects like me, it has never been an issue. Again, you gotta unfold that if you want to see some of that info. And I think you can also obviously see your config file here for reproducibility. So hopefully it's running now. And we're installing some dependencies. Hey, this looks familiar. Test session starts, passed 2 tests, exited with status 0, which is not failure. Great, we've got green. We refresh the page, this guy will change to build passing in a moment. There we go. Amazing. And this is what we want to put on a README so that everyone thinks we have a professional project. You can copy the image address. And then we can make a README finally, which we probably should have done a while ago. We'll call this readme.md. And the only thing we want here is an image. Which has our build passing, because that's the only thing we care about. And you can see that's what it'll look like. I guess we should have a title. A project, and it is passing. Great. Okay, so let's add that README, and we'll see it'll pop up on GitHub. Refresh this guy. Maybe once more. Did it work? Oh no, I misspelled readme. Serves me right for typing too fast. Read me. Nope. Me. There we go. So now we've got our readme over here. Sorry, I kind of glossed over this really quickly, but you can just right click on this and say copy image address for the readme. And then actually to paste it, images are exclamation point, the alternative text, and then this is just the link to the image. And you can see here you could potentially build separate branches. Yeah, you get the idea. Cool. And now our GitHub repo. First of all, we can browse the, oh, and of course it's running the typo build, which it obviously passed because nothing really changed. And one of the other nice things, if in case people actually submit a pull request, that pull request will get run through the pipeline here, and then it'll automate and alleviate some of your concerns that someone's build might or someone's pull request might actually break your project, depending on how thorough your tests are. And then on the actual GitHub repo, we've got this sweet badge that looks sweet. Cool. So that's the basics of Travis. The last thing that I did want to cover today was code coverage. And that's something that we haven't actually looked at yet at all. We may, of course, want to run our tests offline. I think I did add this to my make file. Yeah, PyTest tests. But the other thing that we may want to do, so every time PyTest runs, it has the option to check every single line in your project. So in this case, there would be like 4 and 4 non-white space lines, and check whether that line was actually executed during the run. Okay. So I will add to my make file here. .phone. Oops. Oh no. No, I won't. I'll just add it here. Cov equals project. Okay. And basically, this flag, I mean, you can do the help PyTest and read more about it. But basically, it's saying, OK, run the last argument, run all the Python files you find in tests. But I also want you to check which lines within project actually were run. And so init has nothing. So all 100% of it run. And then test, again, we're checking to make sure that all of these things ran. We expect 100% coverage in this case, because all of these assertions should run every time, and then all the return statements as well. So if we just run the tests here, you can see we have additional output now, which is not only the results from our tests. This is our test session. These are the results on the test. But also now we have a coverage report. And this is saying for every single file, how many statements. So we found 0 in init. And of course, we covered 100% of that. And then in ops, we found 8 statements. So 8 of these lines here. And our tests happen to run all of those. I tried this earlier. If you say like if false, whatever. This isn't actually even going to run as part of the test because it's a little more advanced and it recognizes that this will never be true. So it still only says you have 8 statements, which is kind of annoying. But say we say like if A is bigger than or smaller than F's E -9. which it isn't. So we can see that now we will have less than 100% coverage because this is a potential statement that could get executed. A could be less than this small number, but our test cases never tested that. And so we never reached this line. We did execute this, but we never executed this. And I believe if you look in the coverage file, you can see which lines did run, and then you can infer which didn't. So in this case, I think it would be line 6 is missing here. This file is not super easy to read, but and otherwise tracing where the missing lines are is a bit tricky, but at least you can see what portion of your code is coverage. And I think you can also insert magic comments here. I forget what they are, but like don't check this for coverage. And then you can ignore that in case certain lines won't be executed in your testing for whatever reason, and you're fine with that, and you want to get that 100%. So cool. Let's leave it at 90% for now. And let's integrate our final continuous integration feature, which is CodeCov. And that's going to give us a little badge that just says, how much of our tests are actually, how much of our project is being covered by our tests. Okay. So for that, we'll pop back over to Chrome. Oh, actually, let's update our requirements first. And our requirements are actually now going to be CodeCov, I think. Again, I'm going to open up my old version here, just so I make sure I'm not giving you the wrong one. CodeCov, yeah. Oh, and then also PyTest. I forget exactly the nature of these. I think PyTest Cov is like a wrapper basically for PyTest, and it adds the coverage feature. So you may need to install pytest-cov with pip. I forget. Yeah, so let's add that to the requirements. Of course, I've already done that, so only our Travis will be able to identify that in case I got that wrong. But these should be the requirements that you need now. Okay. We won't push any of this for now, so we'll go over to CodeCov on Chrome. .io. And again, I'm sorry, I don't know. Oh, maybe I can do incognito. Oops. Just see what this looks like for you. And probably you can just log in with GitHub again. Yeah, so there, you could sign in there, and then basically you'll end up somewhere like this. Oh, apparently I need to log in here too. Nice. Cool. So you'll probably see nothing here yet, and you probably won't have this either. The last thing that we need to do is to tell Travis to take the coverage report that gets stored in .coverage here and submit that to CodeCov so that CodeCov can say, what percentage is as a little badge. So in order to do that, we go to here and we say after we finish running our script, I think it's called success. And then we can execute a bunch of additional commands after we succeed in the build. And I think there's some configuration that Travis already has so that all you have to do is write CodeCov, and it will take the coverage report and submit it to the appropriate link on codecov.io, which will update the most recent badge for the repo. think that's the syntax. Again, I'm going to double check with my previous. Oh, after success. And that's just code gov. Oh, and we should also update our script so that we actually generate a coverage report in the same way that we did with our makefile, or however it is that you're running these things. OK. So we should be good to actually execute this. And all code gov is doing really is just generating a badge, but it can also kind of generate an interactive history to show for a given project how the coverage has changed over time, for example. So let's add all this. Some things have changed. And when we git push, the Travis will run. It will succeed, hopefully, and then it will submit the code gov. Oops. It will submit the code gov to code gov, and then we should be good. So we'll push this. Cool. I think at this point, you could potentially add the repository manually here, but I remember having some trouble with it. So probably the easiest thing to do is actually just type your GitHub username and then the name of the GitHub repo, GitHub project.
For what it's worth, I was able to use the add repository button, and I got this copy token screen, but after my latest build, I was able to refresh and make it work. So if anyone else is trying that.
Yes, I think I just built, so it's probably, there we go.
Yeah, that's what I see.
Perfect. And you can see that we have one missing. Oh, and then actually here you can browse. That's the other useful part of this, is that it's a lot nicer of an interface to browse which lines didn't run, besides this kind of mumble jumble file over here. This guy. Cool. Yeah, you can see aspects about the build. You can see some graphs. I have no idea what the heck this means. Cool. Yeah, so you can see what went wrong here. From here, you can also get a badge. Those sweet, sweet badges. That's what we want. And I believe it's basically similar, but here we can say code gov https code gov.io /GitHub chassis ignite project.svg. Nope, that didn't work. Oh, badge. There we go. You can just copy it from here. And you can get it for HTML or RST if you want or whatever. So there's the link. There we go. You can see we got 90%, which is what we expected based on there. And of course, you could just delete this stuff to make it 100%. You know, you get the idea. Yeah, so that's code coverage. That's Travis. Very basically. And maybe we could add this to our GitHub repo. which would trigger another build. But who cares? We just want the badge. There we go. Cool. Again, at this point, I would open it up for questions usually.
Yeah, chat seems empty, but sorry, yeah, go on.
Yeah, no, happy to take if you have any on it.
No, this was all super awesome. This is my first repo with these badges, and now I actually know how they work. I guess one thing I did want to ask is in the make file, what exactly is the purpose of this phony argument, or not argument? I don't even know if that's what I'd call it. But in these key value pairs, what does that do specifically? I was kind of waiting to see if that would come up again, but
right. Sorry, actually, it is unnecessary.
Okay.
The only reason it's necessary, it's actually unnecessary for debug here. The only reason it's necessary for tests is because by default, an argument named tests in the make file will try to execute a file or potentially a folder called tests.
Oh, okay.
Full of bash scripts, I believe. And so this is just a way of saying, hey, don't use the default behavior. Please instead name this argument called tests, but actually invoke the following command.
Okay,
I had to read about that myself. Yeah.
So test itself isn't like a default argument of some sort. We've essentially created it here.
Yeah.
Okay. That's pretty neat.
Yeah, this could also just be run tests, and then this would, and maybe I should have done that to avoid confusion. Oops.
Gotcha. Yeah, Elliot in chat is saying the key is the result of the build rule. Make will look for a file named tests. Yeah.
Yeah.
If a
I
file
think
named
this
tests,
would be equivalent. Yeah. So if you just, it's just because we had a folder named tests.
Okay. Yeah. So we didn't want
That's
that clash to happen. Awesome. And then one other thing was in requirements. At some point, when we were introducing code coverage, we had to switch from PyTest to PyTest-cov.
Yes.
Are those two separate packages? Is that some kind of like?
I don't know.
It's just kind of one of those things where you're like, cool, like this is just how it is.
I forget. Yeah, I think there's actually different packages that build on top of PyTest. So PyTest is the default, and you like if you install PyTest-cov with dependencies, PyTest will get installed.
Okay.
Right. But there are additional options here. So the other one that I have explored is Pylint, and basically that runs a linting, which is testing for like white space, basically,
right.
In your code as if it were a test. And I believe could even fail a test if it's not happy with the linting. You know what I mean?
Yeah, yeah.
So for like really big projects, that can be helpful to ensure, hundreds of contributors are being consistent in their syntax.
Right, and I imagine it has like some sort of PEP8-based kind of checks.
Yes, it's very configurable.
Nice, that's awesome.
Yeah.
Cool. I think that's all the questions I had. I guess we could leave it open to chat for a few seconds. But if not, then anyone listening who might have a question later on, feel free to email us at the email I linked in the chat, and I could forward that to Jesse or get you guys connected. Whatever works out for the question asker and also you, Jesse.
Sounds great. Yeah.
Yeah. Thanks for that. That was super awesome. Sorry again for the hiccups earlier. I honestly should have noticed sooner that it just dropped the audio portion of your presence in the studio, but now we know. Thank you for being our guinea pig.
Yeah, good to know.
Awesome. All right. With that, I'm going to end the live stream. Thanks everyone for tuning in. We can't really do applause of our live stream, but I think if you're sitting at your desk, just a clap for Jesse would be nice, because I think that was a good
F's in the chat.
Or those. I held myself back from doing that, but I did giggle.
Thanks.
All right.
Cool. Thank you.
Yeah, we've got a smiley in the chat, so
Nice.
that's applause for me. All right, thanks everybody.
Thanks.
Thank you guys for tuning in.